Thank you. And you?
Alhamdulillah, sir.
Alhamdulillah, sir.
I wish all of you are fine.
Welcome, sir.
Alaikum Assalam. This is your ME sir in front of you. And this is your second Zoom class, I think, with me.
Yes, sir.
Yes. In my last class, I take a class of chapter number 5 of your half yearly syllabus, and this is another class of chapter 5. So I wish all of you are fine and ready to join my class. And please take your chemistry book in front of you and take a copy with pen. Then you can write some. Is it clear?
Yes, sir.
Okay.
Yes, sir.
So I am starting my lecture. In my last class, I was in these inert gases and their status. Yes, I told
Yes, sir.
about the electronic configuration of different elements, and I mean page 92, and today's
Sir, we
lecture.
can't see anything.
Sir, we
can't
can't
hear you.
we can't hear you, sir.
Yes, sir.
You can't see my book.
So we
Yes,
can.
sir.
So we can see
Some
the book,
sounds
but
are
sir, we
coming.
can't hear you.
So some sounds are coming.
No sounds are problem. Okay, okay. This is page number 92. Is it clear?
Yes,
Yes,
sir.
sir.
Okay, this is page number 92, and my today's lecture is chemical bonds and the causes of their formation. Yes, sir. Okay. Two hydrogen atoms. Basically, my today's topic is chemical bonds and how can they can form a bond. This is my today's lecture. Two hydrogen atoms mutually bond together into hydrogen molecule. So you can ask me, sir, how can make hydrogen two? That means in one molecule, two atoms. How can they combine with each other? I think this is your question. Because the symbol of hydrogen is only H, but the formula of hydrogen is H2. That means in one molecule there are two atoms. Yes, sir.
Atoms of hydrogen.
For that reason, I'm explaining this. This is chapter number 5.
Okay.
Then you can see the structure of hydrogen. You can see the structure of hydrogen here. Is it clear?
Yes, yes, sir.
You know,
Yes, sir.
atomic number of hydrogen is 1. Suppose this electron for one hydrogen atom and this electron for this hydrogen atom. Actually, the property of the electrons of this hydrogen and this hydrogen is quite same, but only to understand both the electrons are coming from two different hydrogen atoms. That's why the color is different. Is it clear? Actually, there
Yes,
is
sir.
a difference in their property.
Yes, sir.
One electron from one hydrogen atom, another electron from another hydrogen atom.
Another.
So by this way,
Another hydrogen.
by this way, they can make a bond and they can produce this H2 molecule. H2 means
H2
two
molecule.
atoms of don't talk anybody, please don't talk. H2 means two atoms of hydrogen. By this way, hydrogen molecule is produced. Is it clear? Okay.
Yes, sir.
Okay. Then, similarly, atoms of hydrogen and chlorine bond with each other to constitute hydrogen chloride molecule. Your question will be, sir, how does this hydrogen and this chlorine can make a bond?
Chlorine.
Actually, by this way, you can see. Suppose this electron, this cross sign electron is coming from this hydrogen atom, and you know the atomic number of chlorine is 17. 1,
7.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, then 17. So this electron of hydrogen can make a bond with this chlorine by this electron. Here, one electron
Yes.
is coming from one hydrogen atom and another electron is coming from this chlorine atom. By this way, they can make a bond. So this is a one form of chemical bond. This is called covalent bond. I will explain it later, but by this way the bond can form. And this is the structure of hydrogen chloride molecule. If I say HCl, hydrochloric acid, then this is right if I write AQ later. And if I don't write AQ later of HCl, if I write only G after HCl, then we can say hydrogen chloride gas. Hydrogen chloride gas. If G is written at the later part of HCl, then hydrogen chloride gas. If AQ is written the later part of HCl, then hydrochloric acid. So I am going to my book again. In hydrogen molecule, a kind of attraction force is effective among the two atoms. In the hydrogen chloride also, there is an attraction force working among the hydrogen and chlorine atoms. So there is attraction between these hydrogen and these chlorine atoms. So by this way, they can attract with each other and they can make a bond. Basically, this kind of attraction force is chemical bond. So this attraction is called chemical bond, meaning the attraction force that forces the atoms to stay together is called chemical bond. So chemical bond is a one kind of attraction by which the atoms are attached to each other. This raises two questions. Why didn't the atoms stay separate, and why did they bond together to create the molecule? So why they can make a bond? Actually, we have already learned that the elements tend to form a stable electronic configuration of inert gas at their outermost energy level. When two atoms of the same element or different element stay close to each other, they donate, accept, or share electrons in order to assume the electronic configuration of the gas. So to make you understand, I'm going to my copy. Okay. Suppose we are talking about hydrogen molecule. Is it clear to you? Okay. Sir, atomic number of hydrogen is 1. So 1 is 1. If two hydrogen atoms attach with each other, when this type of bond is formed, I have showed it in my bottom presentation. You can say both the electrons for this hydrogen atom, and if you put a hand here, finger here, then you can say both the electrons for this hydrogen atom. So by this way, it can follow duet rule. So one electron from one hydrogen atom, another electron from another hydrogen atom. If a bond is formed in two hydrogen atom, so duet rule is followed. So by this way, it can stay. Is it clear to you? Duet rule means two electrons are used to make a bond.
Yes, sir.
I told it in my last class here. Last class, this topic. Suppose for HCl, HCl, one electron from hydrogen, and another electron for fluorine. So by this way, HCl is formed. So here duet rule is formed. One electron from one hydrogen atom and another electron from another chlorine atom. By this way, they can follow a duet rule. And I have already explained this duet rule and octet rule in my previous class.
Yes, sir.
Yes, sir.
I have another thing that is I want to share with you. The atomic number of chlorine is 17. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, then 3p5. Total 17. 2, 4, 6, 2, 4, 10, 12, then 17. If one electron of hydrogen comes to here, then
So you can see that then
3s2 3p6, that is octet is filled up. Suppose this electron of hydrogen, comes to this orbital, 3p orbital, then 3s2 3p6 will form. That is octet will form. Octet will form. By this way, hydrogen and chlorine, they produce hydrogen chloride molecule and it stabilizes. Is it clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
So,
sir.
I am going to my screen share again. So when two atoms of the same element or different elements stay close to each other, they donate, accept, or share electrons in order to assume the electronic configuration of nearest inert gas. So, in case of hydrogen molecule, they share their electrons and it looks like helium atom because by achieving Duet rule, it shows the electronic configuration of helium because the number of electron of helium is 2. Is it clear? And in case
Yes,
of
sir.
hydrochloric acid, when chlorine accepts 1 electron, it, then total number of electrons of chloride ion is 18. So it achieves the electronic configuration of argon. Because the atomic number of argon is 18. If chlorine accepts 1 electron, then it looks like this electronic configuration: 2, 4, 10, 12, then 17 plus 1, that means 18.
Yes,
So
sir.
chlorine achieves the electronic configuration of argon. So it becomes stabilized. Then thus they can create the chemical bond among themselves. Therefore, it can be said that the reason of chemical bonds is the tendency of atoms to assume stability of electronic configuration. Actually, every element tries to be stable. So, to become stable, it donates electron or it accepts electron. Is it clear to you?
Electron. Yes, sir.
Yes, sir.
Yes, sir.
So, what is chemical bond? Actually, chemical bond is one kind of
Tendency.
attraction by which different elements or same type of elements, they can attach with each other. By this way, they can make a molecule. So this is very important part of chemistry. I think all of you understand this topic.
Yes, sir.
Yes, sir.
Okay, so I am going to my presentation again. Yes. Right. 1, 2, 3, 4, 5, 6, 7, 8. So 8 electron for chloride. Okay. Then this is another picture, that is neutral atom. Neutral atom. If we divide neutral atom into two categories, then one will be cation and another will be anion. So how can cation and anion can form? Actually, when neutral atom loses any electron, then cation will form, and when any element gain of electrons, then anion will form. So now we talk about the cation and anion. Cation and anion.
Anion.
So
And
how
I am.
does the cation how does the cation can form? By gaining,
Sir, by loss of
losing their electrons. How does anion can form? By gaining electrons.
By gaining.
So
Yes,
I'm
sir.
I'm going to copy again. So my topic is cation and anions. To know at normal situation, we know at normal situation the number of positively charged proton in the nucleus of an atom is complemented by the same number of negative charged electrons outside its nucleus. As a result, the number becomes charged neutral. So to make you understand, I am going to my copy again. Saying that suppose for magnesium. Suppose so, magnesium. The atomic number of magnesium is 12. Its electronic configuration is 1s2, 2s2, 2p6, then 3s2. You know this. Total number
Yes, sir.
Yes, sir.
of electrons is 12. Here, the atomic number means number of protons. So number of protons is 12. You know the charge of proton is positive, and
Yes,
the
sir.
number of electrons is also 12. So you know the charge of electron is negative. So if you combine this positively charged proton with negatively charged electron, then the total structure of element is neutral. And you know proton stays just inside the nucleus and electron stays the outside of the nucleus in different orbit. Suppose this is first orbit, this is second orbit, this is third orbit for magnesium. So electron stays outside of the nucleus in different orbits and proton stays in, just inside of the nucleus. And if the number of proton and number of electrons are same, then the element will be neutral. In case of neutral element, we don't write any charge here. Any charge here. Is it clear to you?
Yes, sir.
Yes, sir. So I am going to my screen share again. If one or more electrons from the outer energy level is removed from such a charged neutral atom is neutrally will no longer exist, then it will turn into an ion with positive charge. Such ion with positive charge is called cation. What is cation? So I am going to my copy again. When magnesium donates this to electron from its outermost energy, then magnesium when donates to electron, then magnesium 2 plus will form. You can ask me, sir, what will be the number of protons? Actually, magnesium donates 2 electron, not any proton. That's why the number of proton for this magnesium will be 12 and number of electrons of this plus will be minus 10 because 2 electrons are donated. That's why if we combine these two numbers plus 12 and minus 10, plus 12 and minus 10, the charge will be plus 2. This plus 2 we can write here. Is it clear? So what is cation?
Oh,
When any neutral atom donates electron from its outermost energy level, then it will form a cation. And in this case, magnesium 2 plus, there is no electron will be here. So octet state will be fulfilled. Octet state will be fulfilled because 2 and 6, 8 electrons means octet state fulfilled. By this way, magnesium can achieve stability. Are you clear?
Yes, sir.
Sure.
Okay, I am going to my screen share again. As a result, removes exist. Usually, the elements or metal at the left side of periodic table donate one or more electrons to form their outermost energy level to gain the electronic configuration of inert gases become cations. So, you know in the periodic table, in the periodic table, uh, in the left side there will be some metals. In the periodic table left side some metals and in the right side some non-metals, and in every case metal donates electron and non-metal accepts electron. That is the property of metal and non-metal. You know this. In case of group number 1 elements, electron tries to donate 1 electron. For the elements of group number 2, they tries to donate 2 electrons. For the group number 3 element tries to donate 3 electrons. So metal exists in the left side of the periodic table, and they tries to donate electron. And the non-metal, they tries to accept electron to achieve stability. That means to fulfill its octet state. So you know this. Is it clear to you?
Yes, sir.
Always metal donates electron from outermost energy level.
Sir, can you please repeat this?
Metal always donate electrons, and non-metal always tries to accept electrons. Yes, sir. So I am going to screen share again. Such ion with positive charge is called cation. Usually the elements or metals at the left side of periodic table donate one or more electrons from their outermost energy level to gain the electronic configuration of inert gases and become cations. For example, lithium atom donates one electron from its outermost energy level in order to get the configuration like helium and produces lithium 1 ion. So I am going to explain this. I am going to my copy again. You know, the atomic number of lithium is 3. Atomic number of lithium is 3, so its electronic configuration is 1s2, 2s1. If lithium donates one electron from its outermost energy level, then lithium plus will form. Then
Hello.
please don't talk anybody.
Corruption.
Yes, sir.
Rafsan.
So I am
Sandwich-টামি
needing
করতেছে।
all of
Yes,
you.
sir. Rafsan.
So this is lithium 1 plus 1 is 2 will form. In this case, lithium is positively charged ion. That means lithium is a cation. Lithium is a cation here. So by this way, it will achieve the electronic configuration of helium because the atomic number of helium is 2. Its electronic configuration is 1s2. So the electronic configuration of lithium 1 plus is quite similar of the electronic configuration of helium, because here the electron number is 2 and here also the electron number is 2. Here helium is a neutral element, but lithium ion is a cation. Cation means positively charged ion. Cation means positively charged ion. So by this way, elements tries to donate electron to achieve the electronic configuration of inert gases. Okay. I'm going to my copy again. Similarly, sodium atom donates an electron from its outermost energy level in order to get the configuration like neon gas and produces sodium cation. Can you tell why do the metals donate electron to produce cation? Actually, before starting this topic, I want to go to my copy again. In case of sodium, the atomic number of sodium is 11. So electronic configuration will be 1s2, 2s2, 2p6 and 3s1. If sodium donates one electron, then sodium 1 plus will form. Then the electronic configuration will be 1s2, 2s2, 2p6. That means octet filled up. And by this way, sodium 1 plus achieves the electronic configuration of 1s2, 2s2, 2p6. That means neon. Here you can say the total number of electrons of sodium plus is 10, 2, 4, 6. That is 10. And for neon 2, 4, 6. That is 10. So electron number is same for sodium ion and neon also, because this is a cation. The proton number is 11, but this is a neutral atom. The proton number is 10. In case of neon, proton number and electron number are same, that's why there is no charge. But in case of sodium, proton number is 11 and electron number is 10, that's why plus 11 and minus 10 combinedly plus 1. So this is the plus charge. Is it? I think this is okay. This is clear to you. And this is octet filled up. So by this way we can say every element when donate electrons, they try to achieve the electronic configuration of nearest inert gas. You know, the helium and neon, both of them are inert gases. Okay, I am going to my screen share again. Here, lithium, orbital diagram of lithium. When lithium donates this electron, then there is no electron in second orbit. So second orbit is not given here. Only 2 electrons is showed in case of lithium plus. That means lithium cation. We know in any period of the periodic table, elements gradually lose their metallic property as we progress from left to right. Simultaneously, non-metallic property increases in them. In this case, it means the elements of the left side of a period are metal, on the right side are non-metal. Again, the more rightward we progress in period, the size of atom also decreases. So I have to explain this topic to you. You can see that from in a periodic table, in a periodic table, you can see from in the left side only metals are given. In the periodic table, suppose this is group number 1, this is group number 2, this is group number 3. So we can say in the left side metals are stayed, and in the right side this is group number 4, group number 5, group number 6, group number 7. So these are the non-metals. So we can say metals are normally in the left side in the periodic table, and non-metals are the right side of the periodic table. And these group, they are not metal, they are not non-metal. You know, this group is only for inert gases. Here is one thing is explained, that is if we go through from left side to right side, the atomic size decreases. If you go through from left side to right side, atomic size decreases. Suppose the atomic size of aluminum is smaller than the sodium. Suppose the atomic size of phosphorus is smaller than the aluminum. So you can ask me, sir, number of electrons is increased, number of proton is increased, but why the atomic size of phosphorus is smaller than the aluminum, and why the atomic size of magnesium is smaller than the sodium? So I think this is a question to you. So to make you understand, I am going to my copy again. In case of sodium, atomic number is 11. So proton will be 11, electrons will be 11. But in case of magnesium, proton is 12 and electron will be 12. You can see that the less number of protons and less number of electrons, less attraction, less amount of attraction. But more number of protons compared to sodium and more number of electrons compared to sodium here. So more number of protons and more number of electrons means more attraction. That's why more attraction means they come closer to each other That's why the atomic size of magnesium is smaller than that of sodium. So sodium is large in size compared to magnesium. So we can say the atomic size decreases along with a period when we go through from left to right side, because more number of protons and more number of electrons, more amount of attraction, more number of attractions means they come to close each other. That's why its size will be small. According to we are talking about in terms of atomic size. Atomic size. So I think this is very easy topic to you. I am going to screen share again. I think when you read this topic properly, then you will understand the things. Here I have given you the two types of ions, cation and anions. Ion with a positive charge, that is called cation, and ion with a negative charge is called anion. Ion with positive charge is called cation, and ion with negative charge is called anion. So I think all of you understand the things. Okay, then thank you. In my PowerPoint presentation, thank you. In my PowerPoint presentation. So I am coming in front of you. Today I have explained some topic about cation, anion, and how does the elements can make a bond. I think the things is very easy. If you read the topic, then you will